Hello students, today's topic is elements of measuring instruments. Now any instrument or a measuring system can be described generally with the help of a block diagram. Now in this block diagram basically indicates the necessity elements and their functions in general for measuring any system. Now let's look at that block diagram. Now block diagram consists of mainly three components, that is primary sensing element, data conditioning element and data presentation element. Now in primary sensing element, the measurand, that is the quantity which is to be measured, is first detected by the primary sensing element. The primary sensing element then transfers this measured data to a variable conversion element for further processing. The output signal of a primary sensing element is a physical variable such as displacement or voltage or a current. In most of the cases, the transducer follows primary sensing element, which converts the measurand into an electrical signal. Then comes variable conversion element. Now the output signal of a primary sensing element requires to be converted into a suitable variable while preserving its information content. Now this function is performed by variable conversion element, and it sometimes may be considered as the intermediate transducer or a part of a transducer. Then we have a variable manipulation element. Now this element is an intermediate stage of a measuring element. It modifies direct signal by amplifying or by filtering it so that the desired output is produced in the physical nature of the variable, which remains unchanged during this stage. Then we have data transmission element. When the functional elements of a measuring system are spatially separated, then it becomes necessary to transmit signal from one element to another. Now this function is performed by data transmission. It's an essential function element where remote control operations are desired. Then we have data presentation. Usually the information of the quantity which is being measured is communicated to human observer for monitoring, control and for analysis purposes. Now this is therefore to be presented in the form of a human sensory capability. This function is done by data presentation element. Now let's take a look at this figure, which is a simple analog meter. Now in this simple analog meter is used to measure the current or voltage. Initially the moving coil is a primary sensing element. The magnets and the coil together act as a data conditioning stage to convert the current in a coil to a force. Then this force is transmitted to a pointer through mechanical linkage, which acts as a data transmission element. Then the pointer acts as a data presentation element. Clear? Now the proper instrument for any particular of a measurand needs the knowledge of a performance characteristic of that particular instrument. Now the performance characteristic of any instrument is classified into two categories. One is static characteristics, the other one is dynamic characteristics. Now the static characteristics are a certain set of criteria which is defined by the defined for the instruments, which are used to measure the quantity which is very slow, which do not basically varies with time, or which appears to be very slow with respect to time. So they are called as statistic characteristics. Now there are certain different types of various statistic characteristics. These are accuracy, precision, resolution, linearity, resolution, error, sensitivity, reproducibility, zero drift, stability and threshold. Now let's look at these various different statistic characteristics one by one. First is accuracy. Now what is an accuracy? Now accuracy, it's an instrument which can be defined as the ability of the instrument to respond to the true value of a measured variable under a given set of reference conditions, standard conditions. In other words, it's the closeness with which the instrument reading reaches the true value of the quantity which is being measured. That is the accuracy. Then is the precision. Precision is a measure of reproducing the measured value for a given value of a quantity, or the degree of exactness for which the instrument is designed or intended to perform. So precision is the degree of exactness basically. In other words, precision measures the degree of agreement within the group of measurement. Then comes the error. Now what is error? Error is basically the difference between the indicated value and the true value, that is error. Now the most important statistic characteristic of any instrument regarding its accuracy is generally expressed in terms of an error. Linearity. Linearity requires the property that the output varies linearly in accordance with the input. That is linearity. Linearity defined as the ability to reproduce the input characteristics symmetrically and linearly. Zero drift. It is defined as the deviation in the instrument output with time from its zero value when a variable is measured which is constant. The whole instrument calibration may gradually shift by the same amount. That is called zero drift. Threshold. If the input quantity slowly varies from 0 onwards, the output doesn't change until some minimum value of input exceeds. That is the threshold. So the minimum value of an input change is called a threshold. Resolution. It's a simple increment, it's a smallest increment of quantity being measured which can be detected. That is resolution. Means the smallest measurable input change it can measure. Any instrument can measure. Reproducibility. Yes, that's the important para characteristic of any instrument. It's a degree of closeness with which a given value may be repeated again and again. It may be specified in terms of unit for a given period of time. The perfect reproducibility indicates no drift in the instrument. Stability. The ability of the instrument to retain its performance throughout its specified operating life is called the storage life, or it's also called as the stability of that instrument. Then is the tolerance. The maximum allowable error in the measurement is specified in terms of some value which is called tolerance. Range. The minimum and the maximum value of the quantity for which an instrument is designed to measure is called range or a span. Like a thermometer, normally the minimum range is 0 to up to 100 degrees. So that's the range of a instrument. Bias. The constant error which exists over the full range of measurement of an instrument is called bias. Now bias can easily be eliminated by calibration. Now I'll discuss calibration later on. Okay. Now dead space. In some instruments it is possible that till input increases beyond a certain value the output doesn't changes. So for certain range of input values there is no change in the output. This range of input is called dead space. Dynamic characteristics. When an instrument is subjected to rapid variation in the inputs, the relation between the input and output becomes totally different in such cases. Now as the input varies from instant to instant, output also varies from instant to instant. The behavior of such systems are called dynamic characteristic or dynamic response of a system. Now there are certain different types of dynamic responses or the dynamic inputs, sometimes also called as the forcing functions. The first is the step input. It represents the sudden or instantaneous or a finite change in the input. For example, sudden application of a force to a mechanical system. That is the input system. Second is the ramp. Obviously the ramp is basically something which linearly changes with the time. A variable to be measured linearly varies with time. It changes at a constant rate with respect to time. That is the ramp function. Sometimes the dynamic characteristic can also be defined by a sinusoidal, the frequency of the input which changes in accordance with the sinusoidal function with the constant amplitude. Now the frequency is independent variable in this case. For a linear system subjected to a sinusoidal input, the output is also a sinusoidal in the steady state but differ from the input in terms of amplitude and phase angle. Now the various characteristics of dynamic character of an instrument are basically your speed of response, how fast it is actually measuring the response, fidelity, lag, and the dynamic error. Speed of response is it's how rapidly the system adjusts to certain change in the input. It indicates the activeness of the system. The system should respond very quickly to the change in the input. Fidelity, it's the ability of an instrument to produce a wave shape identical to the wave shape of the input with respect to time. It's a degree of degreeness. It's defined as the degreeness to which instrument indicates a change in the measured variable without dynamic error. That's fidelity. Lag. Now every system takes some time to respond, whatever small, or maybe it responds to a certain change in the measured quantity. So this retardation or delay in the response in the system is called lag. Normally all process systems involved in chemical engineering, whether it's a flow through pipe or change in the time or sudden change in the response of flow, they are normally we face across the lag. Then dynamic error. It's a difference between the true value of the variable, which is to be measured, changing with time, and the value which is basically indicated by a measuring device. That's the dynamic error. So the quantity which is to be measured and what is the actual reading of the instrument, that difference is the dynamic error. Now this dynamic error can be eliminated with the help of calibration. So calibration is something like calibration is a process of making an adjustment or marking the scale so that the reading of the instrument agrees with the accepted and the certified standards. That is calibration. Now the standard of a device with which it is being compared is called the standard instrument, and the instrument which is unknown, whose reading is unknown or which is to be calibrated, is called the test instrument. Thus in calibration, the test instrument reading is basically compared with the readings of the standard instruments. So this is what is calibration all about. So this lecture in this lecture we basically dealt with the different types of the elements which are involved in the instruments. We discussed about the statistic characteristics and the dynamic characteristics. So we're going to come across all these terms in further instruments, which we'll discuss for other categories like temperature, pressure and moisture content. Thank you.